Hello everyone. In this lecture, I shall discuss the case of mixed strategy to solve a game. Okay. In the previous lecture, I have discussed the case of peer strategy. Okay. I have also given the introduction to this game theory with basic notations and definitions. Now, recalling our peer strategy case as we discussed in lecture 1, right? If this maximum value is equal to minimax value, right, then it refers to a saddle point. Then this point is the saddle point, right? And this saddle point itself is the value of the game, right? Now, corresponding to the saddle point, the strategies are the optimal strategies, right? The strategies are the optimal strategies. Now, after getting the value of the game, okay, the corresponding strategies are the optimal strategies. For example, suppose you are given a game, payoff matrix like this, We find the row minima, right? We find the row minima. Suppose we mark it by star. In this row, the row minima is star. In the second row, the row minima is 4. Then coming to your column, player B, we have here a column maxima we will find. What is the column maxima? In this column, there is a little correction in the question here. So here in the second row, the row minima is 4. Now coming to the column maxima. In first column, the column maxima is, suppose I denote it by my plus. Okay. In first row, the column maxima is 5. In second row, it is 5. Now the point where both star and plus are marked means this point is my value of the game. So what is the, so my maximum value here from this row point of view, maximum value is 5 here, right? Maximum value is my 5 here, and here minimax value is here 5 here, right? As I have told you, maximum is equal to minimax, then it is the saddle point and the value of the game. So what is the saddle point and the value of the game is here 5. Okay, this is here 5. Now corresponding to 5, the best strategy for B is B1, right? Corresponding to 5, the best strategy for A is A1, right? So this is here A1. So this is the best strategy. So this is what we solve the game if there is a saddle point. Now the question is, if there is no saddle point, right? If there is no saddle point, in some cases we may get also more than one optimal strategy, right? Now if there is no saddle point, what will happen? We cannot find the peer strategy like A1 and B1, right? Then it will lead to the mixed strategy case. The probabilistic approach will come. Okay. So now we will discuss the case of the peer strategy under certain probability distributions. So before we have the detailed discussion, let me to introduce myself. Professor Susanta Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer Surendra University of Technology, Burla, Odisha, India. Okay, so now without much delay, let us now discuss the details of case of peer strategy, case of mixed strategy. There is no peer strategy, so case of mixed strategy. So now there is no peer strategy means we have our mixed strategy and we adopt the probabilistic approach to solve it. Okay. So now the cases of mixed strategy. So here this is applicable to 2 cross 2 payoff only. Okay. If it is a larger payoff matrix, then some other technique is there. We will use the domination property to reduce the matrix to payoff. So in this case, we consider a 2 cross 2 payoff matrix. Suppose the matrix is like this, 2 cross 2 payoff matrix. This is A11, A12, A21, A22. This is my player B with strategies my B1 and B2, and this is my player A with strategies my A1 and A2. And there is, consider a 2 cross 2 payoff matrix, and there is no saddle point, having no saddle point. Okay, having no saddle point. No saddle point. Then what we have to do? Consider the mix. We have the mixed strategies. Let the mixed strategies for A and B are as follows. So for A, we have my essay, right? Essay. So here A is having strategy A1 and A2. Now in probabilistic approach, suppose the chances of A1 is P1 and the chances of A2 is P2. Since it is a probabilistic approach, here P1 plus P2 must be 1. And similarly, here SB, mixed strategy for B. B is having two strategies, B1 and B2. So it is B1 and B2, right? So the probabilistic approach, chances of B1 is suppose my Q1, chances of B2 is suppose my Q2. Then my Q1 plus Q2 need to be 1 because it is a probabilistic approach. Okay, exactly we cannot take A1, part of A1 and part of A2. Similarly, I will discuss again the cases of larger matrix and which will again reduce to 2x2 matrix. Where? Okay, so now we will consider the move of A and move of B as follows. Now you see, from A's point of view, always A like to maximize the gain, right? So here A's gain against B1, so against my B1, this is my B1. So A is having mixed case of P1 and P2. So against B1 it will be A11 times P1 plus A21 times P2. It is A11 times P1 plus A21 times P2, right? And from B2, if A's move against B2 will be A12 times P1 plus A22 times P2, right? And the viewpoint of A is to maximize, right? So this is greater than is equal to B. This is greater than is equal to B. Now from B's point of view, right, against A1 it will be, so B is having the mixed strategy Q1 and Q2. So against A1 it will be A11 times, coming to the first row, A11 times Q1 plus A12 times Q2. And against A2 it will be A21 times Q1 plus A22 times Q2. But the viewpoint of A is to minimize the loss, so it should be less than is equal to B. It should be less than is equal to B. Okay, but this maximize the minimum profit. Now while A wants to maximize the gain, B will not sit silent. Okay, so maximize the minimum profit means the viewpoint here is maximin value against B, and here it is the minimax value. Okay, minimize the maximum loss here because A will oppose here, na? So minimize minimax value here, right? So it will be here minimax value, right? As here A is not sitting idle, so minimize minimax, right? Minimize maximum loss value against here A, right? You see, A doesn't know which beforehand which strategy B will adopt. Okay, A doesn't know which strategy B will adopt beforehand. Similarly, B also doesn't know which strategy will A adopt beforehand. Thus, A has to satisfy with, okay, A has to satisfy with your maximin value, and B has to satisfy with, right, satisfy with this minimax value. Consequently, right, we have to solve for mixed point. We have to solve A11 P1 A11 P1 plus here A21 P2, P2 is equal to V, and similarly A12 P1 plus A22 P2 is equal to V, and similarly A11 Q1, A11 Q1 plus A12 Q2, A12 Q2 is equal to V, and here A21 Q1, A21 Q1 plus A22 Q2 is equal to V. Okay, now we have to solve these four equations. Now solving these four, we have the answer is like this. Okay, so we just need to remember this, right? What is, as you know, here what is your essay? Essay is A1 A2 P1 P2, and here SB is B1 B2 Q1 Q2, and we have to know what is P1, what is P2, what is Q1, and what is Q2, and what is the value of the game, right? And what is the value of the game? So the value of the game, so here the matrix is A11 A12 A21 A22, right? This is the payoff matrix. In view of this is the payoff, matrix. Now what is my V of the value of the game? The value of the game V will be is equal to here this into this A11 into A22 minus A12 into A21. In the denominator, it is simply A11 plus A22, okay, minus A12 plus A21, right? So it just you recall it. Let this denominator be my, I suppose this denominator, because this denominator is going to be used, let I write it lambda. So this will be my, the denominator is my lambda, okay, where lambda is this, where my lambda is this. So it is A11 A22 minus A12 A21. So this is my value of the game. We have to just remember it. Right? Now what is my P now? My P1 is equal to, so for your P1, you see, for your P1 you have A22 minus A21, okay, it is A22 minus A21 by lambda. Once I find P2, you know P1 plus P2 is 1, P1 plus P2 is 1, so what is your P2? P2 is 1 minus P1, okay. Similarly for your Q1 will be this A22 minus A12, right? It is from P1, and it is for your, it is for my Q1, and it is for my P1. So Q1 will be A22 minus, right, this is for my Q1, okay. So this will be my Q2 will be here Q1 will be A22 minus A12, and once I find Q1, here Q2 will be 1 minus Q1, is not it? Because you are Q1 plus Q2 is equal to 1. It is the probabilistic approach here. So this, so in that way we just solve the game. So what is P1, what is P2, what is Q1 Q2, and what is V1? So if you are asked to find the mixed strategy case, we just remember it, okay, we just remember it. So this is my necessary formula, right? So this is the necessary formula, these are the necessary formula here, necessary formula. So for solving the problem, we just need it, okay. We are given a game here, we are given a payoff matrix here, we don't have a saddle point, then we just write this is my mixed strategy accordingly, and this is the formula here to get it, okay. This is the formula here to get it, this is the formula, clear? These are for my P1 and P2, these are for my Q1 and Q2, and this is for my value of the game. This is the thing we need, okay. So this is all about the case of the mixed strategy, and the tragedy of this case here is it is applicable to 2x2 matrix. Later on we will just bring the higher order matrix to 2x2 if possible by using the dominant rule. Coming coming to an example 1, right? In a coin tossing scheme, player A and B match 2 coins, right? If the coin match means head or tail. If it match, then A wins 1 unit, otherwise the payoff is 0. So we have the payoff matrix is like this: player B and my player A, and suppose this is my head tail and this is my head tail. Okay, the strategy are like this. So now if this match, head and head match, then player A win 1 unit. Since A win, it is +1. If B win, then it is -1. Okay, so if it doesn't match, it is head and tail doesn't match means it is 0 here, right? And here similarly tail and head doesn't match is 0, and tail and tail it match means A win 1 unit. If B win 1 unit, then we write -1. If A win, we write +1. Okay, so this is my payoff matrix. Now we have to solve it. So is there any saddle point? You see here, what is the row minima here? You see in this row, the row minima here is 0, and in this row the row minima is 0. In this column the column maxima is 1. So in this column the column maxima is 1. So we do not get any point where both flush and star coincides. Okay, having both star and plus sign means there is no, this maximum value is not equal to the minimax value. Okay, this, so in this case maximum value is not equal to minimax value. So there is no saddle point. Okay, so there is no saddle point. Thus we consider the mixed strategy as follows. So we may just resemble it with A11, A12, A21, A22. Okay, we just resemblance it so that we have to apply the formula easily. We consider the mixed strategy as follows. Let the mixed strategy for A is, here essay is, A is having two strategy, A1 and A2, right? We may call it A1, we may call it A2, and we may call it B1, we may call it B2. So is my A1, A2 having the probabilistic approach P1, and it is my P2, and the mixed strategy for B.Sc is here B1, B2, Q1, Q2. Now we simply just apply the formula. What is the value of the game? What is the value of the game? So let lambda is equal to, here this plus this minus this plus this, A11 plus A22 minus A12 plus A21. So I just find the lambda, means it is 1 plus 1 minus 0 plus 0. So this is equal to 2. This is 2. So what is the value of the game? The value of the game V is equal to, here what, this into this, A11 into A22 minus A12 into A21 divided by lambda. So this is equal to A11 into A22, 1 into 1, 1 minus 0 by 2. It is equal to 1 minus 0 divided by 2 is equal to 1 minus 0 divided by here 2 is equal to here half, right? Is equal to here half. 1 minus 0 divided by 2 is equal to here half. So now the value of the game we got it is here half. Okay, So now coming to what is your P1, your P1 will be this 822 minus 821, 822 minus 821 by lambda. So this is 1 minus 0, 1 minus 0 by 2 is your half. What is your P2? P2 is 1 minus P1 is 1 minus half is equal to your half. Then coming to your Q1. So what is your Q1? Q1 will be this minus this. Okay, this minus this means A22 minus A12 divided by lambda. So it will be your 1 minus 0, 1 minus 0 by your lambda. So this is lambda is your 2. So this is 1 by 2. So this implies what is your Q2? Q2 is 1 minus Q1 is 1 minus half is equal to half. So hence the mixed strategy for A and B are SA is equal to A1 A2, this is half and half, and SB is equal to B1 B2, we got it. Q1 is half, Q2 is half respectively with value of the game, right? V is equal to half, right? So this is my answer. Okay, this is my answer. Now coming to some additional examples. In a coin tossing scheme, if both coins matched, A wins half a unit, otherwise B wins half a unit. If doesn't match, okay, then B wins half a unit. So what is the payoff matrix then? What is the payoff matrix then? Here head tail here. This is your player A and this is your player B, right? We may call it your B1, you may call it B2, you may call it your A1, you may call it your A2. So if both match, okay, if both match means head and head, then A wins half a unit, so it is plus half. And tail and tail, you see here, tail and tail match here, so it is half. A wins means half. Now the moment B wins, it will be what? Doesn't match, but otherwise means head and tail. This place is head and tail, doesn't match. So B wins means minus of half. So here B wins means minus of half. Okay, minus of half. So you resemblance it with A11, A12, A21 and A22 and continue. Okay, and you continue it to solve, right? You continue it to solve. Now coming to one more example. Just you are given solve a game with the following payoff matrix. We have to see here whether there is a saddle point. You see what is the row minima here? The row minima is here minus 2. The row minima is here minus 2. The column maxima is plus 2. The column maxima is plus 2. So no saddle point. No saddle point. So you apply the mixed strategy case. Right? Mixed strategy case. Also here we have row minima. We have to check no saddle point. First we have to see no saddle point, right? No saddle point, right? Then you can proceed. And accordingly, we just resemblance with A11, A12, A21, A22, and you continue. What is your SA? Right? SA A1, A2, P1, P2, and your SB is B1, B2, Q1, Q2, and you continue. Okay, and you continue. Now the thing is that if it is a case of the higher order matrix, suppose you are given a matrix of higher order, right? Higher order matrix is given. So just discussing higher order matrix here. It will be discussed in details in my next video. So up to this, my appeal to all of you is that if you feel that this lecture is interesting and helpful for you, you please like and subscribe to this channel, which will boost my motivation and help me to upload the subsequent videos. Okay, so now if a higher order matrix is given, here suppose A11, A12, A1n, A21, A22 up to A2n. Likewise, here AM1, AM2 up to AMN, right? A higher order matrix is given to you. This is a matrix of order m cross n. Then what we will do? We will use here the dominant rule to bring it a 2 cross 2 matrix, right? 2 cross 2 matrix, and here the rule used is here dominant rule, right? Dominant rule, and we will discuss the dominant rule in the next lecture. Okay, so we should close this lecture here, and in the subsequent lecture I will discuss this case. So thank you all. Please like and subscribe to this channel, and thank you once again. Have a nice day. We should close the lecture now.